In this video, we'll discuss methods of finding the domain for various functions. Now, the domain is the set of all x such that a function is defined. When introduced to an equation, an interesting question to ask is whether there exists particular values such that when substituted in place of x, the resulting equation gives math error or undefined in your calculator. So these are excluded values or restricted values. So let's examine when those occur, how to specify the domain in interval notation, and how to express the domain graphically on the number line. So there's two cases to look out for. When you have a rational expression or division, division by 0 is undefined. So the denominator cannot equal to 0. Now, what if you're given an equation with a radical? Well, the square root of a negative is also undefined. So the expression under the radical, the radicand, must be greater than or equal to 0. More specifically, notice how I wrote even root here. So the root or the index, if it's an even number, then yeah, the fourth root of a negative number is undefined, the sixth root of a negative number is undefined, and so on. Let's look at the simplest case. F of x is 3x squared plus 8x minus 9. Well, this doesn't have any of the scenarios that we mentioned. It doesn't have a radical. It's not a fraction. So by default, all polynomials are defined for all numbers on the number line, from negative infinity to infinity. So if I were to express this graphically, it'd be kind of silly, but I would shade the entire number line. Likewise, suppose you were given g of x is negative 5x cubed plus 12. Again, there's no radical of a variable, and there's no fraction of variables. So by default, I could plug in any number on the number line in place of x into this equation, and I'll always get a numerical result. My calculator will never say math error. So I would shade the entire number line. So those are kind of silly. What about this example? Well, I have the ratio of two polynomials. So individually, the domain of each one would be from negative infinity to infinity. But this x minus 5 is the denominator, so it cannot equal to 0. Adding 5 to both sides, x cannot equal 5. Meaning the domain is the set of all real numbers except 5. So I would shade the entire number line, but 5 is a restricted value. We exclude it. That's what that circle indicates. So that circle means this inequality symbol here. So the domain in interval notation would be from negative infinity to 5, from 5 to infinity. Now, I'm listing two intervals side by side, so put a union between them. That symbol U is called union. I think of it as a comma when I list all my intervals. It means the word or. I'm shading this region of the number line, or my values of x could be this region on the number line. Notice the parentheses indicate that I cannot exactly equal to 5. What about this example here? H of x equals 1 over x squared minus 289. Well, again, I'm just interested in the denominator. X squared minus 289 cannot equal to 0. Adding 289 to both sides. Now we apply the square root property. To isolate x, I square root both sides. I tack on a plus or minus symbol. X is not equal to plus or minus the square root of 289 is 17. This indicates that we'll actually have two numbers on the number line. A negative 17 and a positive 17. Again, we applied the square root property. To isolate x, we square root both sides, but we tack on a plus or minus symbol. Because the exponent indicates the number of solutions we have, we should have two solutions, both a positive and a negative. So I would shade all regions on the number line except at those two numbers. Great, but how would I format this in interval notation? Well, from negative infinity to negative 17, union, the shaded region between these two numbers, from negative 17 to 17, union from our excluded value to infinity. Do you recognize the formatting of the solution? Last time we had one number on the number line. It split the number line into two intervals with one union symbol in between. It's two intervals with one union symbol in between. In this case, our number line is split. We have two numbers plotted. It's split into three intervals. So keep that in mind. And then we'll do additional examples with radicals.